Hey everybody, and welcome back to the Good Tutor Premier Prep SAT course. And in this video, we're going to continue our look, or actually going to finish up our look at the Passport to Advanced Math and quadratics, specifically looking at quadratic systems or quadratic systems of equations. All right, let's see if we can go to our second slide here. All right, so quadratic systems are very, very similar to linear systems, but they're going to contain at least one parabolic or quadratic function, right? So one of those functions is going to be an exponential function as opposed to the normal linear functions or linear equations that we're used to seeing. And typically, we're going to see this in the form of one quadratic and one linear equation. And then solutions, of course, just like in linear systems of equations, are also going to be points of intersection of the graph. So just where is this parabola, right, basically touching that linear graph, right? So in this case, it would be there and there. So solutions are still points of intersection. So those really are the same definitions as when we're dealing with linear systems, right? The system just means more than one equation, and the solutions are points of intersection. So let's get into a couple different examples. All right, so really the method for solving these is going to be very similar, again, to what we're used to in systems of linear equations. So let's go ahead and take a look at this first one. We're told that in the coordinate plane, the graph of y plus 3x equals 5x squared plus 6, and y minus 6 equals 2x intersect at point 0, 6 and hz. What is the value then of z? Basically the y value, right, of that second solution, okay? So we're told these are the two solutions. We know one of them, we don't know the other, and let's go ahead and look at our equations. So we've got this equation here, and this one, that's our quadratic function, right? We see that exponent, that second power there. That means it's not going to be linear. And then we have our linear function right here. Okay, so those are our two functions. The first thing we're going to want to do, though, is get them into standard form. All right, the standard form, of course, are really slope-intercept form, right, for the linear equation, and then the standard form of a quadratic for the quadratic equation. So for quadratics, if we remember, that's ax squared plus bx plus c equals typically 0, or in this case y, right, is what it'll equal because we have y as the other variable. And then, of course, right, for a linear equation, that's going to be, and we'll draw it up here, that'll be slope-intercept form of y equals mx plus b, where m is our slope, b is that y-intercept, okay? So let's start with our quadratic equation. It looks like the only thing we need to do to get that y alone is just get rid of, or move, I should say, that 3x to the other side. In doing that, we will subtract that 3x from each side. Go ahead and show that up there, and then we'll rewrite it down here. So now we've got y equals 5x squared. That was already on the right side, right? And now we subtracted that 3x, so minus 3x, and then plus the 6 that was there. All right? And then for our linear equation, it looks like the only thing we need to do to get that y alone is to move that negative 6, or that 6 that's being subtracted currently, right? So in this case, we'll add 6 to both sides of that equation, and it will result in y is equal to 2x plus 6. All right, so now we've got two separate equations that are both equal to y. The next step is to make them into one unified equation. And the way we do that is by saying, okay, if this quadratic equals y and the linear equation equals y, well, if they equal the same thing, then they must equal each other. So now we'll combine them over here into one equation. So we'll have 2x plus 6. And essentially that's a substitution, right? Because if we see that 2x plus 6 equals y, well, then we can plug it in for y in that first equation, right? When it's being compared on the other side of the equal sign to our quadratic function. So 2x plus 6 is equal to 5x squared minus 3x plus 6 is the resulting equation. All right, and now we want to bring everything to one side. We want to bring all the like terms to one side. So in order to do that, we'll go ahead and subtract 2x from each side. And we will get 6 is equal to 5x squared. Now minus 5x plus 6. And the last step to getting that basically a quadratic that equals 0, right? Because that's part of our standard form typically is equals 0. We'll subtract 6 from both sides, and we'll be left with 0 is equal to 5x squared minus 5x. All right, now we ask, okay, what can be factored out of 5x squared minus 5x? Basically, the 5x squared and the negative 5x? And the answer is 5x. So if we factor out 5x, and factoring out in this case just means really dividing it out of each of the two terms. Well, if we do that out of this term right here, this first term, what's going to be left if we divide out 5x? Just a single x. And then if we, of course, divide 5x from 5x, only a 1 will be left. All right, so now that means that 5x and then times x minus 1 is still equal to 0 because we still have that over here, right? And that means now our 2, if we make this into two separate equations like we're supposed to, right, when we finish up factoring, when we get two resulting factors like that, we'll go ahead and erase our two initial. You can always go back in the video if you want to reference those two full equations. So now we make those into two separate equations like we always do. 5x equals 0 will be 1, and then x minus 1 equals 0 will be the other. That's how we'll get to our final answers, right? To find those x-intercepts, as we call them, or zeros. So 5x, we will divide by 5. 0 minus 5, of course, is still 0, so x equals 0. And then x plus x minus 1 equals 0. Add 1 to both sides, and then x equals 1. All right? So now we have those two. Of course, we were given in the problem, right, that 0 was one of our x's, so we know what the resulting y value is when x is 0. But now, that's the x value, that's h basically, right? Now we just need to know the y value. And the way we do that is we can plug it in to either of our original equations. The easiest one to do that in, of course, was the linear equation. So we'll go ahead and do that. And when we do, we see that y minus 6 equals 2 times x, or 2 times 1, which is just 2. And then if we add 6 to both sides, we'll see that y equals 8. So that other 0, basically, when x was 1, we found that y, or that z value, as they called it in the problem, was equal to 8. Okay? Let's do one more example. All right, so this one will also actually be solved by substitution, a little bit different, just because you'll have substitution within the other equation. We're not going to isolate, we're not going to get these into standard form because it would be quite a bit of work to get that first equation there into standard form, so we're not going to worry about that. This one we're going to go straight into substituting. All right, so if we know these two are, they are what they are, right? We have x squared plus y squared equals 10, and then y equals negative 3x plus 10. So we have a substitution again for y. So we will plug all of this into that first equation for y. So we'll have x squared plus, and now instead of y squared, right, we have negative 3x plus 10. We can do that because that equaled y squared is equal to 10. All right, now, of course, we have to expand this power, and we do so by a method known as FOIL, which stands for first, outer, inner, last, and that just signifies the things that we're going to multiply as we go. So, of course, we have x squared, right? But then we have negative 3x plus 10 multiplied by negative 3x plus 10. And we say first, outer, inner, last, meaning the first two, multiply those. The outer two, which would be the negative 3x and that 10. The inner two, which is these two. And then the last two of each parentheses, basically, in the 10 and the 10. Okay? So we'll multiply that out that way using the FOIL method. And when we do, we have x squared, of course, comes over still, plus 9x minus 60x plus 100 is equal to 10. All right, from there now, we just have to combine the like terms, which really just means bringing this 10 over to the left side, which is subtracting 10, and then actually combining these as well. Oop, and that should actually be 9x squared. Excuse me. So then actually these two will combine, x squared and 9x squared will combine. Those two will combine because they are like terms, and they'll combine into 10x squared minus 60x plus 90 is equal to now 0, right? So now we have a standard form quadratic, which is really always our goal here. Now we can see that every term in this resulting quadratic can be divided by a number, and that number happens to be 10. And this is just a matter of simplification. So if we divide each of these by 10, we see now that we've got x squared minus 6x plus 9 equals 0. And from here, we can actually factor this directly. So now we have to ask ourselves what I like to ask myself when I get to these, remembering this is ax squared plus bx plus c equals 0. That's the standard form quadratic, right? I like to ask myself what adds to b and multiplies to c. It's a good way of thinking about these when we can factor, especially when our a value up here is 1 like it is in our case. So we need something that adds to b and multiplies to c, or adds to -6 and multiplies to a positive 9. And if you were thinking about that, then that answer is actually -3 and -3, right? They add up, -6, they multiply, but it becomes positive to make -9. So the answer to this one is x minus 3 squared equals 0. Now remember, just like we did on the last one, let's clear up that 0. Just like we did on the last one though, right? These are our resulting factors. So x minus 3 is our factor, but in order to actually find our x-intercept, or the x value, or the solutions as they're referred to, right? They kind of go by a bunch of different names. We have to make them an individual equation equal to 0. So x minus 3 equals 0, add it, 3 to both sides, and you find that x equals 3. So 3 is actually the solution. A positive 3 is the solution to this. While x minus 3 and x minus 3, because it's x minus 3 squared, may be the factors, the final solution is a positive 3. Right, and that is actually it for our look at the Passport to Advanced Math. Up next, we'll start our videos dealing with problem solving and data analysis.